Chapter 8, Objects and Classes, Part 5. So object references, when you create an array, for example, if you want to make double square brackets values equals new double 5, that creates an array of 5 double values. And what's stored in the name values is the address of where that array is. Not the array itself, but the address of the first element in the array. Similarly, when you create a new object, you say the name of the class, like cash register, the name of the reference, say reg1 equals new cash register. Ooh, there is a typo after that new cash register on that slide. It needs a set of parentheses after it because it is calling a method. It's calling the constructor method. So reg1 will contain the address of where that object is in memory. So it is a reference. You can share references. For example, we created reg1, that's a single reference. But if you say cash register reg2 equals reg1, it doesn't make a copy of the object stored at the address referenced by reg1. It just copies the address into reg2. So essentially, we've created an alias for the same object. They are both referencing the same object. There's only one object in memory, but two names for it. So if we want to perform a primitive copy, such as looking at primitive values like int num1 equals 0, int num2 equals num1, what happens is it makes a copy of the value in num1 and puts it in num2. They are not linked. So if we increment num2, we are only incrementing num2. We are not also incrementing num1. However, when you make a copy of a reference, it does the same thing. It just copies it. However, because the address is the same, you're referencing the same object, you're making a copy of the address, not a copy of the object stored at that address. So it's a little bit difficult to wrap your head around, but think of it as two names for the same thing. So when either one of those object references accesses a mutator method, that object will be mutated for either reference. The null reference is a way to say that a reference points to nothing. So there is no object there. You've created the reference, but you're going to use it later, for example. In the gray rectangle, see cash register reg equals null. So it does not have an object. So when we try to call reg.getTotal, we're going to get an error because there's no object that has the getTotal method. Reg is referencing a null object, so it references nothing. So if we want to well, let's look at one more example. Say string middle initial equals null. That's also a reference that's set equal to nothing. And we could check for it. If middle initial equals null, we don't include one, else we do include a middle initial. The this reference is an implicit parameter passed to every instance method, and it is a reference to the current object. So if we call the instance method add item, for example, it would get the formal parameter double price, but it would also receive an implicit parameter, which we refer to as this, and this is a reference to the current object. So this dot item count, that means it will reference the instance field item count. We could say this dot total price, that will reference the instance field total price. We could also call a method. We could say this dot clear is one of the methods inside the cash register class. So this references the current object. You can use this in the constructor. For example, sometimes if we name our parameters the same thing as our instance field, that's kind of clever because we could say, okay, public student int ID is going to be the parameter that I will store into the instance field. However, if you name a parameter the same thing as an instance field, the parameter masks that instance field and you can no longer access it. But you can access it if you use the this reference. So if we say this.id, we are referring to the instance field ID, and then we set that equal to ID, which would be the parameter ID. Note the difference. The blue one in this image is the instance field, and the green one is the parameter. It's a common error to not realize that you have not initialized an object. For example, if we're creating a bank account class and we have an instance field that is a private string name, the default constructor will set name equal to null. So if inside an instance method like showStrings, we try to reference name.length, that will be an error because name references null. There is no name.length because name does not have an object there. Similarly, we will get an error if we try to say string local name and then access local name.length because that also does not have an object. And the error there would be variable not initialized because it's a local variable as opposed to an instance field. Both examples are errors, however. A constructor can call another constructor, and this might be handy for code reuse if you want to only update the constructor method in one place, for example. So if you look at the default constructor, public bank account, we're calling this with a 0 in the parentheses. That calls the one argument constructor and will initialize the instance field balance to initial balance, in this case 0. When this is followed by parentheses and 0 or more parameters, it denotes a call to the constructor. This is the only way to call the constructor. And this is not a technique that's used in our textbook, and so it's just kind of extra. You can skip it if you want. Variables can be declared as static. Remember that static means that it exists when no objects of the class exist. So you might want to, forgive me, you might want to create a static variable that's going to keep track of the count of the number of objects or the count of an assigned account number or some other thing that's shared amongst all your objects of the class. So static variables are shared amongst all objects of the class, and they exist when no objects of the class exist. Using static variables, each time a new account is created, the last assigned number variable can be incremented by the constructor. So you keep track of what was the last one I used so that you can use it for creating the new one. And note that we can access a static variable by using the class name dot the variable name. Let me back up for just a second. Yep, sorry. And here we have college fund, mom's savings, Harry's checking. Each one of these gets an account number when it's created, and notice they go in sequence, assuming that we've created college fund first, and then mom's savings, and then Harry's checking. The Java API has many classes that provide methods you can use without instantiating objects. The math class is an example of one that we've used. Math.square_root or math.pow or math.max or min. And those are static methods. You do not need to instantiate the math class first because they are static methods. You just say math dot to access them. So you access a static method by using the class name dot and then the name of the static method. You can write your own static methods by starting with public static and then the return type, the name of the method, and the parameter list. Static methods usually return a value, but not always, and they can only access static variables in methods. The reason for this is if you create a static method and you try to access instance fields, they may not exist when you call that static method, so that would be a runtime error. So Java doesn't let you do that at all.